Hey guys, Justin here. I thought I'd do a new tutorial on creating your own bus board for Eurorack. So I've gone ahead and started a new project and called it Bus Board. You can see up at the top here. So let's go ahead and kick it off. We're going to go to the EE library, which is the built-in library for EasyEDA. We're going to scroll down until we get to the IDC headers right here. You'll notice that right now it's a 2 by 3 pins, so it's a 6-pin header. We're going to change that because we want to create a bus board. We want to have 16 pins, which is a 2 by 8, so we'll choose this one. Once you change the selection on here, you have to click on it in order to get it, and we'll drag it here. Alright, so we're going to have 10 of these eventually, but I'm only going to do the first one so I can copy and paste it. So let's go ahead and rename that power. Right, so we know that the negative 12 volts is on pin number 1. So we want to put that at the bottom just for conventions. So we're going to put the negative 12 volts here at the bottom, and we've got the other pins here going vertically. So we could just wire these all together with the bus, the different connectors. We could copy and paste this 10 times and then wire them all together. But we don't want to do that. So instead we're going to use something new that I haven't covered called the net ports. So go ahead and click on net port, and then we're going to drag it down here and place it there. We're going to skip the 3 ground pins, and we're going to place 4 more net ports. Okay, we're going to right click to get rid of that, and we'll double click here and we'll call this one minus 12 volts. Okay, we're going to double click here, 12 volts. We know we've got the 5 volts here, and we've got CV, and finally gate. Now we want this to be on both sides, so we're going to copy, do a Control C and a Control V. We're going to hit the R key twice to rotate it around 180 degrees, and we're going to do that for each of these. Control C, Control V, rotate, rotate. Alright, then we got 5 volts, Control C, Control V, rotate, rotate. 12 volts, Control C, Control V, rotate, rotate. And finally 12 volts, minus 12 volts, Control C, Control V, rotate, rotate. Alright, there we go. Now we want to wire up these ground pins, so let's go ahead and grab the wire. We're going to connect these like that, and we'll connect these guys here. And then what I'm going to do is I'm just going to come out here a little bit for clarity. And we're going to click on the ground symbol, connect it up. I'll put one of those over here as well. I'm going to hit the W key, which is wire. That's the same as clicking on the wire, and connect them. Now remember, just to check that our net ports are connected, you can grab one and drag it around. You should see that wire move. That tells you that that's connected. Alright, so there's our first connector. We're going to need a grand total of 10 of these. So let's go ahead and copy this. We're going to highlight the whole thing with the box, left click and drag, and then we're going to do a Control C, Control V, and we'll paste these right next to each other. Of course, you want to keep your schematics as tidy as you can. There we go. So now we have 5. You'll notice that it's automatically numbering these P1 through P5. And go ahead and grab all of them. Left click, drag, and click again. Control C, Control V, just like any other copy and paste. And we'll place them down here. You'll notice that it goes 1, 2, 3, 4, 5, and then it goes 6, 7, 8, 9, 10. Doesn't really matter, but just keep that in mind as we copy and paste things. Alright, so that takes care of our connectors for our bus board. We're going to go ahead and save this, and we will generate a PCB by clicking up here to convert schematic to PCB. It'll do a little bit of its work here. Now remember that EasyEDA tries to guess at your size of your PCB when it first gets started. So we're not going to use that. We're going to switch to inches here, and we're going to say start inch is going to be 0. I mean start X is going to be 0 inches, and then start Y, we're going to put 1.25 inches. Actually, let's make it 1.3, and then width is going to be 10 inches wide, and we'll take the height is also going to be 1.3, and we'll hit apply, and that gives us the starting point for our bus board. Now we need to rotate these guys because we want them to go vertically, so let's go ahead and highlight them and move them a little bit out of the way and hit R once. That gets us rotated. If you look at these pins, right now we can't tell which pins are which, right? But if you zoom in at a certain point, you'll see the text pop up on each pad. So this is the minus 12 volts, which is also indicated by this caret symbol. That's the number 1 pin here. So that's what we want on the bottom. Now all we have to do is drag these. Now you see that the numbering's a little weird, so we want to get them in order. So I'm just going to drag them one at a time, roughly into position. Not worrying about trying to line everything up perfectly, but I just want to get them in order. 4 is here. So you know, to move around EasyEDA, just like any other drawing program, you click down on the center scroll wheel, and that gives you the pan function, and then using the scroll wheel zooms you in and out, which you'll be using quite a bit. Let's go ahead and move all these in order. 8, 9, and finally 10. Alright, so we got them roughly in order. There's a few different ways we can align these. One of the ways would be to check, put our snap the way we want it, and then to go ahead and use that to line them up. I'm going to highlight them all, and up on the top here you'll see align horizontal centers. So that's going to get these guys all lined up. And then also I want to space them out across this board. So I'm going to leave a little room on the end. Let me go ahead and work with our snap here. Let's see, canvas attributes. Remember, to get there you right click on the background and go to canvas attributes, and then our grid is currently at 0.1 inch, and so our snap is really small. We want to make it 0.05 inch, which is going to be half of one of those grids. So now you'll see it snaps in nicely, right? We can get it centered that way. So that's the height that we want for that. Let's see here. If we highlight all these guys again and we get them up there, and then now they're still highlighted, so I can grab them and snap it up like that. Okay, so what we want to do is space these out evenly. You can do that with snaps. So you can just like drag it here and then count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's not the easiest way to do it, but that's one way to get precision snap alignment. We can also just drag this over here, and we're going to leave a little room for a connector, and then let's highlight them all. Oops. Let's highlight them all, and we will do this item here, which is distribute horizontally. If I click that, you'll notice that we get a nice even distribution for all of our connectors. Alright, what's next? So now we can wire these guys up. We're going to go ahead and use a ground plane for the ground on this bus board. So we're just going to wire up the connectors here. Let's go ahead and go to the bottom layer by clicking on the blue here, bottom layer, and we'll hit the track key or the wire key, or the wire icon. You can also hit the W button. We're going to click on the first pad, and we're going to drag that all the way across. There we go. Now we just connected all those across. If you remember, that's the gate signal, which often isn't used, but you want to include it. So let's go ahead and let's talk about the track size. So that right now the track is, if we click on it, over on the right we see that the track is 0.01 inch in thickness. So let's just go to 0.05 and see how big that would make it. Alright, there we go. I think that's pretty nice. A little bit smaller than the pad size, but that gives us a nice signal. So now it's going to remember that we just changed the track size, so when I go to the next one, you'll see that it's already at that larger size. It just defaults to whatever the last one you did. So it's pretty quick work to connect all these guys here. Now remember, we're going to use a ground plane for the ground. so I don't want to connect the grounds, and I'm going to connect that minus 12 volts, and there we go. Alright, so we've got the passive part of our bus board completed. Now what we want to do is we want to add some capacitors for smoothing the power, and then we also need a connector to get the power in and another connector in case we want to daisy chain the power out. So to accomplish that, let's go ahead and save our work. Always a good idea. We're going to wait until this little asterisk goes away. I don't have the fastest internet here, and remember it's saving in the cloud, so sometimes saves can take a little bit of time. You'll notice down at the bottom here I've got the connecting to server. Alright, got saved successfully. That took a while. Let's go back to our schematic. Alright, so we want to add the capacitors in. I'm going to show you a quick trick on how to figure out which capacitors we want to use. So we're using electrolytic capacitors. That's this CELE. The TH stands for through hole. If you click the down arrow, you have a whole bunch of choices for footprints. These top ones are all surface mount, right? We're not going to do that. We're using through hole. So we have sizes that go from 3 by 1.5 all the way, and that's the diameter by the height, I believe. And then as we go down, we go all the way to 12.5 by 5. So what we're going to do is we're going to just put one of each of these in our schematic. So I'm going to click here and drag it and put it there. Now I'm going to change to the next one, which is 5 by 2, and then I have to click again to get that one active. If I didn't click, it would just put that same one that I started with there. Okay, so now we're going to go here, we're going to do the 6.3 by 2.5, click again, drag. We're going to do the 8 by 3.5, click and drag. Now I'm not going to use all these capacitors, I just want to show you a trick here. So I'm going to click again, and then I'm going to do it again for the very last one. Alright, so now we have a whole bunch of capacitors. I'm going to go ahead and update our printed circuit board. It's going to warn me that these aren't connected, right? But I don't care about that right now, I just want to see what they look like on the PCB. So I'm going to say no, keep going. I'm sorry, I forgot to update. I forgot to save it. You have to save before you can update your printed circuit board. So I just saved successfully. I will update. It's going to warn me. Say no, keep going. And it's going to tell you what it's doing. It's adding all these capacitors and the nets that go with them. And we hit apply changes. We can close out the design rules window, and let's take a look at what we got. So we've got C1, C2, C3, C4. These are the different sizes, right? So I'm going to pick a fairly large one. I'm going to use, let's use C4. I think that looks like a good size for what this bus board has. So let's go ahead and pick that one. So let's go back to our schematic. We're going to use C4, I said, so I'm going to highlight the rest of these and delete them. Alright, so C4, I'm going to rename that C1 by double clicking on the C4. And then I'm going to rotate it until I have the plus on top. There we go. And then I'm also going to change the value to 100 UF. Alright, now I want 3 of these guys because we have plus and minus 12 volts and plus 5 volts. So I'm going to copy and paste it. I'm going to copy and paste it. There we go. Now what we've got to do is wire up the middles to the ground. I'll just go like that. And let's grab the ground symbol right here. Connect the minus 12 volts. Now how much smoothing capacitors you have, that's entirely up to you. I am not an electrical engineer, so I'm not a good authority. This is just what I'm doing. For example, you could add your like 100 nanofarads for the high frequency, but I'm not going to do that on this bus board. I'm just going to stick with this here. So now we have that, and then we also need the input and the output connectors, right? So let's go ahead and take a look at that. If we look at Google Chrome, I've gone to the TIDA website, and I decided on using these wafer connectors, right? So we would need a 4-pin wafer connector. Let's see, right here is a right angle one. That might be the one we choose. So that's what I decided to use for this bus board. So let's go ahead and look for that library. Alright, so we go over to the regular library here. And if you search on Molex wafer, like I've already done here, you'll get over 1,000 user contributed Molex wafers connectors. So I just chose this one, a 4-pin Molex wafer male, and it has a footprint right here. Take a look at the footprint, looks about right, and we've got our schematic symbol here. So I'm going to go ahead and I think I got to click on it again and then see how I can place it. You may have noticed there's a little warning at the bottom corner. It's telling you, hey, this is submitted by someone, a user. It hasn't been verified, so use at your own risk, basically. Okay, so I'm going to put it on here twice. I'm going to right click and then I'll close this dialog box out. So now we'll call this power in and power out. Alright, now we just need to grab our net ports and paste them in here. So I got a 5-volt one, got my minus 12 volts, put that here. Okay, let's grab plus 12 volts. Alright, and then we just need our ground, so let's make a wire, make it a little bit clean. When you want to terminate the wire, you right click. So I'll just drag it out here, right click, and that terminates it. And let's choose the ground symbol. And we do that, and then we save our work. Alright, we saved successfully. So now we have our whole bus board schematic done. I'm going to go ahead and update the PCB. It's going to give me the dialog box that shows exactly what it's doing. Now I have on occasion had issues where it just gets stuck in this loop. When that happens, let's just close it out, and you can see it's failing to connect to the server for some reason, probably because of my slow internet. So I'm going to try again and see if I can get through. Okay, it's not looking hopeful, so let me go ahead and pause this. Okay, so after a bit of waiting, I did get it to go through, and you'll see that it comes with this dialog box that confirms the changes that we're making. So it's replacing capacitors, it's adding the jacks, and it's removing the capacitors, the ones that we didn't use, and doing all that. So let's apply those changes and take a look at what we got here. So now we have our 3 capacitors and our 2 jacks. Now we don't know for sure which jack is which, so let's go ahead and highlight the jack, and we're going to turn on the display name. That tells us that one's the power in, and then they'll do the same thing for this one. Go over here to display name, power out. There we go. Alright, so let's put our power out jack over here roughly, power in jack over here. I'm going to put these capacitors by the input. Okay, I'm going to rotate this guy. Let me zoom in here. You can see that this one pin is 5 volts, so I'm going to put it like this so it kind of matches up. You can see the rat lines. Alright, capacitor 1 is going to be between 12 volts and ground. So I'm going to put the ground at the bottom. Alright, rotate it a couple times. Let's see, this one goes to the negative. So I'm going to get that lined up right, like that. And this one has got to be the 5 volts. And we'll line that up like that as well. Okay, let's get these guys kind of centered on the board, give it a little more space. There we go, that looks good. Got a nice design. Okay, let's go ahead and go to the bottom layer, and we're going to do our traces. So we're just going to do nice straight traces. This one I'm going to bring it down here. Let's see, let's go here, click, go here, here, and there. So if you want to set the exact path that your trace takes, that's how you do that. We're going to click here, click, connect, click, connect. Alright, this is the ground, so we're not going to mess with that. And then we'll come down here, do something like this. and like that. Alright, so now we got our that part of our bus board done. Not the prettiest. Let's change this one just for aesthetics. Let's go like this. Let's go up a little bit, and then over like this, and like that. I think that looks just a little better. Matches. Okay. Now let's do our power out. Again, we're going to check. We want. Whoops. Let me check. Click on it and rotate a couple times. There we go. Now we got it lined up. Let's get it centered on the connector here, and then let's do our connections. This one's pretty easy. It's going to be straight across, down here, and then I'll just go like that. There we go. Now we want this fell off the board here, so let's go ahead and grab that and rotate it. Place it there. I can leave the J2 there, it looks okay. This one's a little hard to read, so let's move it over here. Remember that the silk screens go on top of the traces, so you can put it there, it will be easily visible. And you can move this J1 down here. There we go. Alright, so all we have left is to do our ground plane and some holes, right? We need some mounting holes. So we're going to click on this icon here, which is a hole. It's got the circle with the 4 quadrants sticking out. And let's just go ahead and set it right there for now. That's in the intersection of the 0.1 grid, 0.1 inch grid. And we're going to highlight that one. If you look at it, the default is 0.080 inches. Let's go ahead and change to millimeters since our fasteners are in metric. Click on the hole. It's at 2.032 millimeters. That's too small. So we want to use 3 millimeter, but you wouldn't want to make your hole exactly 3 millimeters. So I'm going to go ahead and make it 3.2 just to give a little clearance. And hit enter. That looks good. I can copy that and paste it. Control V, and I'm just going to stick it in the corner. And stick it in the corner here. Corner here. Alright, let's paste one here roughly in the middle. Let me check on that one. That one's, let's see, if we change to inches, that one's at 5.1, so let's put it at 5 inches, so that's right in the center. Okay, copy that one, paste it up here. Alright, and then let's see if we can put one on 2.5. That's 3.2. Might not be able to, but let's see. There we go, 2.5. So we got 2.5. We're going to paste that there. And then we want 7.5. That's 7.8. So it looks like we're not going to be able to do 7.5. Let's see what that is. That's 7.2. Alright, so I can't do an exact spacing. I got to make a decision here. I'm going to put it right there. Okay, again, you can space out your connectors as far as you want. Alright, so now all we have left is a ground plane. So we're going to choose this icon here, which stands for copper area, which shortcut key is E. We're in the bottom layer right now, so we'll click on this, and we want to use the ground plane. We're going to click on OK, and now we have to define the corners of our ground plane. We're just going to click there, left click, drag over here, get it lined up, left click, go up here, left click, and right click at the end. Okay, it built our copper area. Now what we want to do is we want to go to the design manager and do a refresh here. These all have check marks, so they're all good. We can also expand the DRC errors, run that again, and there's no errors, so there's nothing's hitting each other or anything like that. So the last step here before you'd want to order it would be to put any kind of graphics you want on it or anything like that. Let's go ahead and look at the 2D rendering. This is what our bus board looks like in 2 dimension in the 2D photo. You can switch here to the bottom side. Look at that, looks good. This is where all the traces are. Alright, okay, let's go close this guy out, and we can also look at a nice 3D rendering. Now because we chose components from the main library, those ones have 3D models. But you'll notice that the header the power out and the power in do not have models. That's because those are user submitted footprints, right? So there's our very simple, basic Eurorack bus board. Just for fun, let's save that guy and let's see how much this would cost to make. I'm going to pause the recorder while I wait for my internet. Alrighty, so it finished saving. I'm going to hit the G button here and I will check the design rules. Let's see what the estimate is here. $7.04, that's for 5 bus boards, and so we can change that to 10 bus boards and see what the price goes up to. $10 for 10 bus boards, so you're paying about $1 something for each one. Now keep in mind you still have to do shipping, so that's another concern, and shipping is going to be expensive. You're going to pay $15-20 for shipping, something like that, depending on where you are in the world. So you have to factor that in, so the price does go up. But it's still, you know, let's say you wanted 20 bus boards, you're looking at $17, so the price keeps going down. You can change your color. They got red, yellow, blue, white, and black. When you change the color, it slows down the building a little bit, but it does. But you can choose your color, so it'll take a couple extra days usually. You can change your copper weight, and the price will go up as well. Let's see. Well, it's not updating now, but yeah, you can change lots of different factors on your once you actually go to order. Oh, there it went up to $40, right? So I don't think you want the 2-ounce copper. You probably want the 1 ounce. All right, guys. Well, I hope you enjoyed this video. If you do, please like the video and subscribe, and feel free to leave a comment if you have any requests, something you'd like to see, something you want to know how to do. Even if I don't know how to do it, I'll learn real quick and try and share that with you. Again, I appreciate your viewing, and I wish you the best with using EasyEDA to make your Eurorack modules.